Greetings, welcome to this short video on Introduction to Terraform. So what is Terraform? Terraform is an infrastructure as code tool. Infrastructure as code is a method of managing and provisioning resources using machine readable definition files instead of manual processes or like interactive configuration tools. Here's an example of Terraform code that's written in HCL, that is HashiCorp Configuration Language. It's a domain-specific language for dealing with Terraform. These are the key Terraform concepts that, if one understands well, can use Terraform in their day-to-day operations. So let's take a look at these one by one. So first up is providers. Terraform providers are plugins that connect Terraform to various cloud platforms and services. They enable Terraform to create, manage, and update specific resources like virtual machines, databases, etc. within these platforms. Think of them as a translational or translation mechanism between Terraform HCL and the target cloud provider's API. Next up is resources. So resources represent the infrastructure components like servers, databases, VPCs that we define in our configuration files. This is what Terraform creates, modifies, or deletes to achieve the desired infrastructure state. Speaking of state, Terraform state is a file that keeps track of the current configuration and resource status in your infrastructure. It helps Terraform determine what changes to make during subsequent operations. These are the commands that you use in Terraform. So if you start with Terraform init, which downloads the provider. This downloads the provider binary for you. So that the Terraform provider binary is the one that does the translation from the HCL to the cloud API. After that, you run Terraform validate. Now, the validate command checks the syntax and internal consistency of the Terraform configuration files, and it makes sure that your files are formatted correctly and are free of errors, but it does not check for logical errors. It only checks for syntactical errors. Then you can run a Terraform plan, which is sort of a dry run before you apply and make permanent changes. This gives you an output of resources that Terraform will create, modify, or destroy. Once you're happy with the plan command's output, you can do a Terraform apply, and this would actually provision the resources as defined in your configuration files. Now, the Terraform destroy can bring down the resources once you're done with them. Okay, let's take a look at demo to understand these concepts in more detail. So what we're going to do here is pretty simple. We are going to provision a virtual machine onto the Google Cloud platform. As you can see right now, I only have one virtual machine, which is the Vehicle Dynamics Calc website VM. We are going to create another virtual machine here, and we're going to call it Terraform Demo Instance. It's going to be a E2 small machine type, and it's going to have it's going to be having a Debian 11 boot disk image. To understand how to create these resource files, you can go to registry.terraform.io. Once here you can browse the providers that you would like. Remember that providers are the binaries that help convert your HCL to the cloud provider's API language. Okay, so since we're operating with Google Cloud Platform, let's go click on GCP. Now, once you're here, you can see, if you click on use providers, you can see the Terraform block that helps you define which version of the provider that you want to use in case you want to log that in. If not, Terraform pulls in the latest version every time. You can click on the documentation to get more details on the provider. So since we're creating a compute instance, let's search for compute instance. So here you can see the provider block configuration. So it shows you that you need to define the project and the region. So if you go back to our code, you can see that we have the provider Google and we have a project and region. Note that this is known as a block. So this is called the provider block. This is a resource block. The way that you define Terraform components are you have the resource block, then you have the type of resource, and then you have the name of the resource. So see, this can be called as my first VM. So if you have any other resource that you define in Terraform and you want to refer to this block, you would refer it as resource, resource dot Google Compute Instance dot my first VM. So that's just a small aside on how the naming convention works. So let's go back to the documentation and check the compute instance definition requirements. So if you go to the Google Compute instance, it shows you here how a resource example can be defined, and scrolling down you can see the argument reference, and it tells you which of the following arguments are required and which of them are optional. So the boot disk, machine type, name, and network interface are required. So if we go back to our code, we can see that we have the boot disk, machine type, name, and network interface. Once we're happy with our resource, we can first go ahead and run Terraform init to get the provider binary. So this creates a .terraform file, .terraform directory for you in which you have the provider binary. Next, it also creates a .log.hcl, but that's for working with multiple Terraform users, so we're not going to look at it at the moment. After this, you can run a Terraform validate to ensure there are no syntactical errors in your configuration file. After which, you can run Terraform plan to see a dry run of resources that would be created. As you can see, we have an error here. It failed to receive zone process ID. It says zone, which is a required field, is not set, and it tells me the resource in which this is not set. If we go back to the documentation and see zone, it says it's optional, but it says the zone the machine should be created in, if it is not provided, it would use the provider zone. But if we go back to our code, we can see that in our provider block also we have not mentioned the zone. So let's go ahead and mention zone in the resource block. So zone US West 1P. Okay, now after I have added the argument for zone, I see that it's not in line with the rest of the definitions. There is a Terraform command that you can use to fix this, and it's named appropriately, called Terraform format, Terraform FMT. And this goes ahead and formats all your Terraform configuration files to have the equal to sign in one line. It does some other formatting functions as well. Okay, so once that's done, let's go back and run Terraform plan. So now you can see, just an aside, the way that the Terraform is currently authenticating to my Google Cloud resources is because I ran a command that I can show you here. Terraform auth application default login. Once you run this command, it opens up a new tab in your browser, and then you can select the account that you want to use, and then it says you're now authenticated with gcloud CLI, so you can now run the Terraform. So Terraform would be using the credentials saved to the JSON file in your gcloud API. Okay, now we can go ahead and run Terraform plan, and you can see that Terraform would be creating one resource, which is the Google Compute Instance resource. And you can see that a lot of these fields will be known after you apply. So that means after the resource is created is how you would know which network IP it has, etc. So let's go ahead and run Terraform apply. Okay, now it gives you so if you see on the left, it says it's created a state log file and it's created a .tf state file, and it gives you the same resource that you want to create. So you can go ahead and type yes if you're happy with it, and it's creating the VM now. So if you go back to the Google Cloud Console page, you should see a virtual machine being created here, as you can see here. So you have a Terraform demo instance. And we go back to the code, and you can see that the apply has been complete and one resource has been added. Now, if you want to see the list of resources that Terraform is currently managing, you can run Terraform state list command. This shows you all the resources that Terraform is currently managing. Furthermore, if you want to get details on any of the resources, you can run Terraform state show and the name of the resource. So now a lot of these values that we previously had seen as known after apply have been populated. So you can see the CPU platform, you can see the IP address for the instance. And once we're done with the resource and say it's no longer needed, you can run Terraform destroy. Oops. See, as you can see, now the red negative sign is what Terraform shows you to indicate that it's going to destroy. Before I run destroy, I want to show you something else. I've explained that Terraform uses your configuration file, and this is the final state that Terraform wants to create, and it manages that using the terraform.tf state. So your main.tf is your desired configuration. The Terraform state file is the current configuration that Terraform is aware of. And Terraform, whenever you do Terraform apply, it reconciles the differences between your desired configuration and the current state. So now, as we saw in the Terraform state list, there is one virtual machine here as defined in my configuration file. Now, if I go ahead and comment out this configuration file, and I run Terraform plan again, you can see that Terraform knows that this resource is no longer existing in my configuration file, but it exists in the Terraform state file, so it would want to destroy the resource to reconcile my configuration file with the real Terraform state. So if we go ahead and do Terraform apply now, and then say yes, now this virtual machine will be destroyed on the Google Cloud platform. Okay, so it's still destroying. As you can see, about a minute later, the instance has been destroyed, and if we refresh the console page, we no longer see the instance. So that was a relatively quick and short introduction to Terraform. Thank you for watching.